This AP question from FRQ question from 1989 AP Physics B, and now these sections are covered in AP Physics 2. And in this question, they say that a series circuit consists of a battery of negligible internal resistance, a variable resistor, and an electromotor of negligible resistance as well. The current in the circuit is 2 amperes when the resistance in the circuit is adjusted to 10 ohms. Under these conditions, the motor lifts a 1 kilogram mass vertically at a constant speed of 2 meters per second. Determine the electrical power that is dissipated in the resistor, used by the motor in lifting the mass, and then supplied by the battery. So to calculate the power dissipated by the resistor, I have the power formula, which is I times V. And because I know the current and I know the resistance, I can replace my voltage using the Ohm's law, I times R. Then I will get the formula I squared R. So if I plug in the numbers, I have the current, and they give you it is 2 amps. So that's 2 squared times the resistance, which is 10 ohms. So that is 10. And that will give me 40 watts power. So that's the power dissipated by the resistance. For the second one, they ask you to calculate the power that is used by the motor in lifting the mass. So the power, so this was A, and then for the B part, to find the power, it's the work over time. And for the mechanical power, so I have the work, which is force of gravity, or the tension. In this case, because the velocity is constant, your tension is equal to the force of gravity. So if you look at the mass, you have tension, you have mg, and you have acceleration, and it is 0 because it's moving at the constant velocity. So in this problem, we have force times the distance over the time. And this formula is usually not given, but can be derived this way. It's the same as force times the velocity. So far, I'm using these formulas. And this is what's given on AP exam usually, and this is what's given on AP exam usually. But everything else that we derive usually is not given on AP exam. So if power dissipated by the resistor is 40 watts, then the power for the motor is the force of gravity, mg, and then the velocity. And that will be mg, so the mass is 1 kilogram, so mg gives me 10. And then I have velocity, which is 2 meters per second. So I have 10 times 2, and that will give me 20 watts. And then the next one is the power supplied by the battery. So both the resistor and the motor running off the battery. So that means the battery supplies 60 watt of energy per second to run the motor and resistor at the same time. For the next question in the problem, they say or ask to determine the potential difference across the resistor. So the potential difference, or the drop of the voltage on the resistor, the voltage is measured parallel to the resistor and measured by the multimeter when it is set up on voltmeter measurements. And that I can use the Ohm's law, which is I times R. So the current is 2 amps, and then the resistance is 10. So that will give me 20 volts. For the next question, so this was 20 volts. For the next question, the voltage that is dropped on the motor. So again, if I wanted to calculate the voltage dropped on the motor, I'm going to have my voltmeter connected parallel to the motor. So I'm calculating the voltage in this area between these 2 points. And for that one, I could use the power formula. So the power formula said that the power is equal to I times R, I times V, or I squared R. Or you can also replace I with V over R from Ohm's law. So if you ever replace I with V over R, you can also rewrite the formula as V squared over R. But on AP exam, only this part is given. But I can use this and find the voltage dropped. I know how much voltage is dropped on the motor, so I can calculate how much power is dropped on the motor. So I can calculate the voltage is equal to the power over the current. Because they are connected in series, they have the same current flowing through them. So this current is 2 amps through the battery, through the resistor, and through the motor. So if I do my calculations, I have the voltage through the dropped on the motor is equal to the power on the motor, and we calculated it's 20 watt, divided by the current through the motor, which is 2, and that gives me the voltage dropped on the motor is 10 volts. So right here, I'm going to have 10 volts. And then they ask you how much voltage does the EMF battery or EMF of the battery or supplies to the circuit. And if you have the battery and then you have one source and then you have another source, I always tell the students to look at the voltage or the EMF that the battery supplies as the amount of money you have when you leave the house. So when you leave the house, amps or little aliens will leave the house. They will go around the circuit. They will pass through this room. They will pass through this room, and then they get back home. So when they have certain amount of money that they're living with, by the time they get home, they have to spend all of it. So they will spend some here, and they will spend some over here. So wherever they spend here and here together should end up as much as they had when they left the house. So if I am dissipating 20 volt of potential difference on the resistor and 10 on the motor, then together the battery supplies 30 volt of the potential difference. For the next question, they ask you, they say that the resistor is now adjusted until the mass rises vertically at the constant speed of 3 meters per second. So the velocity here, it changes to 3 meters per second. And the voltage drop across the motor is proportional to the speed of the motor. And the current remains constant. Determine the voltage drop across the motor, and then determine the new resistance of the circuit. So when they say that the voltage drop is proportional to the motor, what they mean is the voltage on the motor is equal to some coefficient of proportionality between the motor and its velocity. So when the motor had 10 volt drop on it, so when we had 10, the velocity was 2. So from here I can find that K is equal to 5. So that is the coefficient of the proportionality between the voltage and the velocity. Now when I have 3 meters per second velocity, coefficient of proportionality is the same because it's still the same motor. So that one is 5. So I know that the voltage drop on the motor now is 15 volts. Because the battery provides the the voltage by the battery provided is 30 volts that we calculated earlier. The battery is still the same. It's the resistance that changed. The motor is still the same. That is lifting the mass. But now the voltage dropped on the motor is 15 volts. That means the voltage drop on the resistor is also 15 volts. But the current provided is still the same because they didn't say that the current changed. So the current or the motor has to be operating at 2 amps. So that means that the resistance now has to be that the voltage dropped on the resistor through over the current. And that will give me 15 over 2, because this 15 and 15 will give me 30. So the resistance, the dissipating resistance of the voltage on the resistor is have to be 15 volts. So that gives me the resistance is 15 over 2, 15 volts over 2 current, gives me 7.5 ohm. And then determine the new resistance of the circuit, which is 7.5. And then for the previous question, when they ask you to drop, the voltage drop on the resistor is 15 volt. So the voltage is 15 because they together have to make 15. And we can figure out what the voltage on the motor right now. So subtracting it from 30 gives me voltage dropped on the resistor is 15. And then divide by the current in the circuit, which is 2, gives me the resistance of 7.2 ohms. And that is all I have for this question from 1989 AP Physics B. And thank you for watching. Subscribe if you're learning from my videos. And I hope I see you in my future videos.